What's up, you freaking geniuses? So in this video, I'm going to teach you how to identify similar polygons and shapes. Okay, and I'm also going to show you how to find different lengths, angles, and scale factors. All right, so let's start with this example right here. So this problem says, are the polygons similar? If they are, write a similarity statement and give the scale factor. So here we're given two triangles, this one on the left and on the right. So ABC and DEF. So to compare these two triangles and see if they are similar, first we need to check that they have congruent angles, right? All three angles in one triangle have to be the same as all three angles in the other triangle. So here it's pretty easy to tell, right? Obviously, this angle is congruent to this angle. This angle right here is congruent to this angle right here. And then lastly, angle C is congruent to angle F. So check, check, check. Those are all the same. Now the next thing we have to do is compare the ratios of the corresponding sides. Okay, so all that means is we have to compare similar sides. Okay, so let's start with this side right here, side AB. Okay, side AB. We're going to compare that to what side on this triangle over here? Well, as you can see, AB runs from angle 1 to angle 2. So on this triangle, that would be side DE, because DE runs from angle 1 to angle 2, right? So AB, we can compare it to DE. Now, when we compare these two, let's compare the lengths. So side AB right here, you can see is 8 units long, and DE is 10 units long, right? So we get 8 over 10, which we can reduce that down to 4 over 5. Okay, so when we compare the two sides right here, it gives us our scale factor. So the scale factor between those two sides is 4/5. All right, so now let's compare the other two sides and check to see if we get the same scale factor. And if we do, then that means these are similar triangles. But if even one of these is different from the others, then that tells us that they are not similar triangles or shapes or polygons. Okay, so we checked AB, now let's check BC. So side BC corresponds to which side over here? Well, BC runs from angle 2 to angle 3, so that would be angle 2 to angle 3 on this one, right? So from E to F. So from E to F. So BC, the length is 12, and EF, the length is 15. So the top and bottom are divisible by 3, so again, we can reduce this down to 4 over 5. Okay, so those have the same scale factor as well. Okay, but again, all three sides have to have the same scale factor in order for them to be similar, right? So lastly, let's check this side right here, AC, all right? So AC, as you can see, runs from angle 1 to 3. So over here, that would be DF, right? From angle 1 to angle 3. So again, that's DF. So side AC right here is 16 units long, and DF is 20 units long. So the top and bottom are both divisible by 4. So again, we can reduce this down to 4/5. All right, cool. So since all three sides have the exact same scale factor, 4/5, then that means these two triangles are similar. So if we wanted to write a similarity statement, we could simply say that triangle ABC is congruent to triangle DEF. And they have a scale factor, again, of 4/5. All right, here's the next example, and the instructions are going to be the exact same. So again, the first step is always checking if the angles are congruent. And in this case, it didn't just give us the little symbols, right? We actually got some numbers here. Okay, so on this triangle, on the left side, we have an angle of 43 degrees. And over here, we're given these two other angles, 63 and 70. So the important thing to remember here is that all the angles inside of any triangle always adds up to 180 degrees, right? So if this one's 63 and this one's 70, well then this angle right here must be 180 minus 63 minus 70, and that's equal to 47. Okay, so this angle is 47 degrees. So as you can see, this angle that it gave us, 43 degrees, does not match any of the angles within this triangle. Okay, so again, all these three angles have to be the exact same as all three of these angles, and obviously they're not, right? So that means these two triangles, we don't even have to check anything else, they are not similar. All right, now for this next problem, as you can see, we have a big trapezoid right here and then a smaller one that's tucked right into it, okay? And now I'm telling you that these two trapezoids are similar. Okay, so for this example, we're gonna try and find the lengths, these missing lengths of x and y. And the way that you do that is by setting up proportions. So you want to, let's just start with x. You want to set up a proportion by using the missing side. So this missing side, x, as you can see, is along this side right here from E to F. Okay, so E to F, that corresponds to which side on the big trapezoid? Well, that would be this top side, right? From B to C. Okay, so E to F corresponds to B to C. Okay, so here's our ratio. And now we want to set this equal to another ratio so we can set up a proportion. And the other ratio that we want to use is just two sides that we already know the length of. So for instance, we know the length on the small trapezoid from A to E, right? It's given to us as 6. So we know this side on the small trapezoid is, what is it, A to E. Okay, now this small side corresponds to which big side on the big trapezoid? Well, it would be from A to B, right? Because it gives us that total length is equal to 9. Okay, so let's just fill in what we know. So the distance from E to F, again, is equal to x. The distance from B to C is equal to 5, and then we're going to set that equal to this one over here. So A to E, let's see, A to E is equal to 6, and A to B is equal to 9. Okay, now to solve a proportion, you just need to cross multiply. So we're going to multiply those two guys together. So 9 times x is just equal to 9x, and you set that equal to your other cross. So 5 times 6, which is equal to 30, all right? So then solving for x over here, we can divide both sides by 9, and 30 divided by 9 is equal to 3.33333, but I'm just gonna round to 3.3, okay? Or we could also write this as 3 and 1/3, either one. All right, so x is equal to 3.3 repeating, right? So now that we know what x is equal to, now let's solve for y. Okay, so again, we want to set up a proportion. So we want to take this distance from F to G. So we're going to say F to G, and that corresponds to this big side over here from C to D, right? And we're going to say that that's equal to a proportion that we already know, some numbers that we have that were given. So again, we can use this one over here. So from A to E on the small trapezoid, and that corresponds to, again, the big trapezoid from A to B. Okay, so now that we have our proportion set up, now we can start filling in our numbers. So F to G, again, is just y. And that's going to go over C to D, which is 7.5. And that's equal to A to E. A to E is equal to 6. And A to B, again, is 9. Okay, so to solve for y, again, we can just cross multiply. So we're going to have 9 times y, which is 9y. And that's going to be equal to 7.5 times 6, which is equal to 45. All right, so solving for y, we can just divide both sides by 9. So here we get that y is equal to 5. All right, cool. So now we know what x and y are equal to. Okay, here's the last example. So again, I'm going to tell you that these two shapes are similar. So again, that means all the angles in here are the exact same as all the angles in here. And all the sides are proportional to the corresponding sides over here. Okay, and as you can see, we have two unknown side lengths, right? We have this side from O to A, which is represented by 3x minus 2. And on this one, we have this unknown one, which is x plus 4. All right, so in order to solve for x here, we need to, again, set up a proportion. Okay, so let's find the first ratio. And we want to use whatever side we're looking for. So for this big polygon, this big quadrilateral, we don't know this side right here from O to A. All right, so this side right here, 3x minus 2, is from O to A. Now, this side corresponds to which side on this polygon over here? Well, it looks like from O to A is the longest side. So then the longest side on this one, it looks like it's from R to E, right? From R to E, which just happens to be the missing or unknown side also, okay? So we're gonna set this again to equal to a ratio that we do know. So in this case, we can say, let's just use some easy numbers. So from L to M, which is opposite of that really long side, is equal to 4, right? So we know that side. So we can say from L to M, and that corresponds to which side over here? Well, again, it would be opposite of the long side. So it looks like it would be from K to T, right? From K to T. All right, so let's fill in some information here. So O to A is 3x minus 2, 3x minus 2, and RE is x plus 4. And again, we're going to set that equal to LM, which is 4, and KT, which is 3. Okay, so again, we need to cross multiply. So we're going to multiply these two guys together. So first of all, we have 3 times 3x minus 2, and we're going to set that equal to our other cross, 4 times x plus 4. Okay, so now we can distribute, first of all, this 3. So if we do that, we're going to get 9x minus 6, and that's going to be equal to 4x plus 16. Okay, so let's get all the x's on one side. So minus 4x, and let's get the numbers to the other side. So here we can say plus 6 and plus 6. Okay, so 9 minus 4 is equal to 5. So here we get 5x is equal to 16 plus 6, which is 22. Okay, and I'm just going to rewrite this up here really quick. So 5x is equal to 22. So to solve for x, we can just divide both sides by 5. So then here we get that x is equal to 4.4. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.